so you should see it, instead of like a normal P, kind of looks like that. And this is supposed to be kind of slanted and like, I don't know, it's like almost a curvy kind of thing. Anyway, this is RHO, row.
RHO. Can I draw a little like the bottom of each one?
You can do whatever you want, buddy. Okay, so identify the null and alternative hypothesis. We've got the level of significance, degree of freedom. This time it's n minus 2. So that's something to notice.
Would they accept like random syllables that not syllables, no, letters that look different on the AP test?
No.
If I was funny about it, like top.
No. Okay. One more time.
Yeah.
Just one more time, Gustavo. Don't try to be funny or take shortcuts on the one day it matters.
Okay. So
I spent an hour drawing a top hat on this P, and they didn't appreciate it or give me points. Yeah, I bet they didn't.
So if I made my bell chart into a sombrero, they would that's
I'm sure some grader somewhere would go,
yeah.
and then go, well, no, that's wrong. Unless you're also right. If you are also right, and you're doing so well that you have so much extra time that you're like, let's make a sombrero, normal distribution, yeah, do it.
So if the P hat's right, it's fine.
Yes, sure.
Well, you'd have to look like peanut, right?
Yeah.
As a fancy peanut.
Little
You know, those fancy
P
P's
with
and
like
stuff,
a, yeah, little baseball cap. P hat.
Well, thank you, I appreciate that.
All right, so next up, you find your standardized test statistic, you decide rejector, is it nice? I mean, I know it's annoying that we keep doing so many of these things over and over again, but hopefully you feel very comfortable at this point with writing in null and alternative and all that stuff. So let's give it a shot. Null and alternative. All right, so right now what we're trying to do, this is actually a pretty important hypothesis test, is we're trying to see, anybody know what GDP stands for?
Gross domestic product.
Good. So this is how much our gross domestic product for a country is, also compared to their CO2 emissions. So we're seeing if the country makes more money, generally, if they're releasing more CO2 into the atmosphere, and if these things are related. That'd be pretty interesting if it turned out to be a negative correlation, because what would that mean?
Or maybe less emissions.
You're right. The more money you make, the less emissions you. That would be very surprising to me, just because of what I know about stuff. But I guess possible. All right. So let's go through and give this a try. First, we have to start with the null and alternative. So the null and alternative, which is here, is that there, so again, you're doing this kind of slanty P, this row. The null is always going to be that it equals 0, and the alternative is going to be that it doesn't equal 0. This is the one test where you will always, and I do mean always, well, you're always going to use 0, no matter what, but it could still be a two-tailed, left-tailed, or right-tailed test, where you would say, so whenever it says is significant, that is a two-tailed test. Because it could be significant with a negative correlation, or it could be significant with a positive correlation. Does that make sense to you guys? Okay, but if they were saying we think it's a positive correlation, then that would be a greater than. Everybody okay with that? But the number that we're always putting it against is 0, because that would be no correlation. Okay? All right. So now, let's see, we've got alpha equals point, what was it? 0.05? Okay, so grab your T-charts. This is two tails. Two tails as 0.05, or does that make sense to you guys that one tail would be 0.025? Okay, what should we go down to? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, minus 2, 8. And they're pairs of data, so that's easy to remember that it's gonna be -2 instead of -1. Okay, so I'm getting positive and negative 2.306.
Is there a way to put plus or minus into like computer, or does he actually put plus or minus each time?
Usually in programming at least, it'd be two different codes.
Okay.
Negative 2.306 and positive 2.306. That's what I'm kind of hoping a little bit to do with a master's degree, is not only do data science as in like statistics, but also do data science as in coding and stuff like that, so that I could do better at pushing kids towards coding and answering their questions. But anyway, here's my note. Okay, we're gonna do this with our calculator. Our t value is going to be r over the square root of 1 minus r squared over n minus 2. But we have to find r in our calculator first. So right now, go into Stat, Edit, and in your lists, you're going to put in these two columns.
Does it matter which one goes where?
It only matters if you can, make sure you keep like the L2 as L2 later, but they'll not switch around on accident.
No, it doesn't matter.
Oh yeah, this
Okay, does everybody remember where to find how to get your R now?
it's the lin, right?
Linear regression, yeah. So stat, calc, and then you're picking linear regression, and make sure that your X list is listed as your X list. So this is where it matters, Tegan. My X list was my L1, and my Y list was my L2, so just make sure they say the right things.
What's the other linear regression for?
What are you talking about?
Goes the A plus XB instead.
That is like if I wanted to make a line of best fit that fits the data. A would be my slope and B would be my y-intercept. So I got, what'd you say?
So is this opposite of this one?
What?
Like the A and B are flipped?
No.
Okay. So actually, okay.
So a correlation coefficient, which is R, is not the slope. And it is not it is positive if the slope's positive and it's negative if the slope's negative, but it's always between 1 and -1. It just tells you how well it fits the data. If you wanted to write an actual line equation,